ladies and gentlemen. Hello and welcome back once again to the longest running show in the world about data. It's time for DM Radio. Yours truly, Eric Kavanaugh, here with a couple experts in the field. We're going to be talking to my good friend Hyoun Park of Amalgam Insights, and we have Kishore Gopalakrishna as well on the call with a company called StarTree that's doing some very interesting things in the world of data. And a couple quick thoughts about the topic: a Pinot for your thoughts, next gen observability. Yes, okay. Pinot is an Apache project. Of course, it's also a wine, Pinot Noir. The wife loves that, Pinot Grigio. So people know Pinot, but it is an Apache project, and we're going to talk about that today. We're going to talk about observability and really meta observability to a certain extent, and what that all means. And Gopala spent some time, or Krishna, I'm sorry, Kishore spent some time over at LinkedIn, and before that at Yahoo. And of course, LinkedIn is where Kafka came from. And Kafka has taken the data world by storm with its ability to stream tremendous amounts of data. The problem with Kafka is that there's a bit of an impedance mismatch. So they came along, figured out this great way to set up topics that stream tremendous amounts of information, but how you capture that and do things with it becomes a bit of a challenge. And being able to analyze it as it's flying across the transom, that's kind of the holy grail, if you will. And that's what these folks at StarTree have figured out. So being able to analyze data as it arrives, that's very compelling, because if you have to wait for the warehouse, well, how long does that take? Is it an hour? Is it a day? Is it a week sometimes? You never know, depending upon the installation. And let's face it, sooner is better, especially if bad things are happening. You want to know right away. If good things are happening, you also want to know right away. And then observability, what is that? We're basically now able to see into these environments, into the data pipelines, for example, into the data sources, and understand what's flowing and what's not flowing. So you get a baseline, you understand what's supposed to be happening, and then with observability, you get early warning alerts basically that something isn't right. And so that's great for data teams because they know, all right, we got a problem here, we have to fix something. So they can go in and fix it, and you don't wind up making decisions on bad data, on missing data. There's a lot of technical aspects of getting this all right, but it's very important. And I was sat on the call when I talked to StarTree a couple of weeks ago, as they told me about the technology. I was like, you're reminding me of another company we did some work with, a company called Mesmo. And what they do is they sit on top of observability feeds, and they allow you to select the signal you want to keep, and also just persist in maybe cold storage, all the other stuff that you don't necessarily need. Because the fact is, once you start with these observability vendors, whether it's New Relic or Datadog or any number of them, there's like 20 or 30 of them these days. At first, there's not a whole lot of data, but as time goes by, there's a lot of data, and you wind up spending a whole heck of a lot of money for storage. And on the other side of the equation is that it's always in the correlation of these feeds that you're going to find your insights. So how do you correlate? How do you reconcile data feeds from 5, 6 different systems? It's very difficult to do. And the folks at StarTree are also working on that in particular. So I think it's very interesting technology. It is very good for keeping the machines running on time, the trains running on time, if you will. And that's just crucially important in today's hybrid cloud world. And with that, Kishore, I'd like to bring you in to tell us a bit about StarTree, what you're working on, and where the idea came from, maybe. So tell us about StarTree, Kishore.
Yeah, absolutely. Again, first of all, thank you so much for having me on the show. That was a great intro and a great segue into kind of why we built Apache Pinot and also why we started StarTree. StarTree is a company that provides real-time analytics platform as a service, and is built around Apache Pinot project that you kind of hinted at in the beginning. And one of the key things that we really built this for was really bring analytics to the masses, right? So when I say that, it's like something that we found at LinkedIn, that analytics should not be restricted just to the execs, right? I think I touch upon this part of decision-making process that you also mentioned that, and that has evolved quite significantly in the last decade or so, right? And I think when I think about decision-making, there are two parts that comes to mind, which is really the quality of decision and the speed of decision making, right?
Mm-hmm.
And quality, I mean, we all know, I think this has been there for since the start of big data, is like you need to make decisions based on data, right? You don't want to just make decisions out of your previous information or any kind of hypothesis that you have. And the second part is the speed, and that's where Pinot came in, right? Which is the events are happening. Why do you have to wait for the next day to actually make those decisions on the data?
Hmm.
So that's where we were able to provide those insights to make quick decisions. And you don't have to wait for another day or two. And I think the second, which is very interesting and something that we found at LinkedIn, is there is also a major change here on who is making the decision. I think that was a very important factor for us to build this project, which is if you go back 10, 20 years ago, it was only the execs or the product managers who were making the decisions based on data. It almost used to be this luxury that you had in the company that only for some people could have access to this data. But that is something that we found at LinkedIn that everyone should be making decisions. It should not be restricted to these elite people within the company, because the more decentralized decisions that can be made, the better it is and the faster the company evolves. And not just that, what about your users and what about your consumers, right? So LinkedIn, we thought about what decisions are the members of LinkedIn making, and that's kind of what changed the whole game for us in terms of thinking about analytics as it's no longer something that's batch, and it's no longer something that's restricted to some certain set of people within the company. Can we make it real time? Can we open it up for the entire world? And that was like a kind of an experiment, I would say, to begin with at LinkedIn, because we were also trying to solve the engagement problem. But it opened up a completely new set of data products that we could build. And then if you see LinkedIn today, like pretty much any number on LinkedIn, it's basically a real-time analytics
Wow.
powered by Pinot, right?
Yeah, and so I've been in this analytics space for a long time. I first got into it back in 2001, and I just knew that data was going to be big, and I also knew that analytics was going to be huge, and being able to crunch the numbers and really get an understanding of what's happening, that's the key to analytics, and it's
Yeah,
all about, to your point, making better decisions. It's funny, we talked about business intelligence for the masses 23 years ago. It
yeah,
took us a little bit longer than I expected, but it's here now, and I think Kishore, my impression is that once someone can see the analytics and use that capability, they don't want to go back. It's like
yes.
being able to flip a light on in a dark room. You don't want to turn the light back off and try to find stuff. You want to
Yeah.
turn that light on and see. Isn't that right?
Yeah, no, absolutely. I mean, a lot of people, I think one of the things that when I talk about this, people say like, I don't need it. And I'm like, hey, you're using it on a day-to-day basis. You open up your Uber Eats app and you're actually looking at how long, which restaurant am I going to pick? And then you're picking based on like how long it's taking to serve that. Guess what? That's real-time analytics. Real-time analytics doesn't mean that you need to see a chart and it's like, it's any number that is actually computed in real time. That's basically the definition of real time analytics. And imagine now going back, and if you want to order something, someone calling a restaurant and then calling multiple restaurants and asking how long are you going to take to order to serve this order, and then making a decision. There's no way we are going back to that, right? And with all the Ubers and DoorDash of the world, this like completely changed the way we think about food, the way we think about travel. You're no longer calling a taxi to actually go to from one place to another. So this is like the change has already happened, and it's just more about people noticing that and seeing that, hey, there is something behind the scene that's actually making it possible.
Yeah, and you bring up another excellent point here, which is that what we see in the consumer world is driving tendencies and expectations in the business world. You
Yes.
think about how Uber revolutionized the whole ride sharing concept and getting a taxi service basically. And let's face it, yellow cab and taxis were just living in the Stone Ages.
Yeah.
And all of a sudden, when you can see the car around the corner on your phone,
Yeah.
that's a huge deal. And we're seeing the same thing now in the real business world because people can see what's happening. And when you can, at the other side is comparisons. When you can compare what you're doing with what other people are doing, and you can see that comparison, it's really a strong driver for change and for efficiency, right?
No, absolutely, absolutely. I think in other words, there is also this consumers are actually forcing businesses to evolve, because this is becoming almost like a competitive edge. And at the same time, the consumers are very demanding right now, right? And if you think about it, if someone on the other side, let's say Uber, doesn't know sudden surge in some demand in some area, let's say there is a sudden event that happens, and if they don't react to that, And if they are not capable of knowing that, they already lost that advantage, right? And someone else would have acted on it, and someone would have capitalized on it. So it's almost like becoming like a going from like a nice to have, it's a good competitive edge, to is like you got to have this. Otherwise, your customers are actually moving to another platform because they have so many other options.
Yeah, yeah, that's an excellent point. And over the course of the show, I do want to get into the weeds with you a bit about how Pinot is different, what StarTree is actually doing, and how that all works. But before we get there, let's bring in our esteemed analyst of the show today, Hyoun Park from Amalgam Insights. Hyoun, you've been around this business for as long as I have, and you've seen the changes, and it's really quite tremendous what's happened in the last decade and even in the last half decade with all of these solutions spinning out of the tech giants like Facebook and LinkedIn. Originally, it was Yahoo. That's the first diaspora came out of Yahoo. But now you're seeing all kind of cool stuff come out because these folks have been at the coal face, as they say. They've been tackling these issues, and they're issues of scale more than anything else, which is a whole separate set of problems. But what do you think, Hayan?
Yes, so there's a variety of challenges here, and I still have to think about what if Jerry Yang had been able to keep it in control at Yahoo, because he really did understand all these scaling issues. But whole other story right there. When I think about data in general, I tend to think about it kind of in terms of Heisenberg's uncertainty principle. That there's always these complementary variables that are coming into place, like such as speed versus what is actually happening. Call it the momentum or position. These things are always in flux. You can know one, but not the other. As we're getting more real time, we've had this challenge. You can either understand your data in extreme detail, or you can get it updated. That has traditionally been kind of the trade-off that we've made, that comparison to position versus momentum that exists
Hmm.
for uncertainty. But what we are seeing that as we are seeing order of magnitude increases in data, as well as greater demands for real time. We're having to find ways to bring those two closer and closer together. And that has required different technology paradigms to be created over time. So for instance, when we started in data, we were all used to looking at structured data and traditional relational databases and input output that was pretty limited and required batches basically. We had to schedule those batches. Sometimes they take hours to upload and download, and we don't live in that world anymore, frankly. Those were the technical barriers that honestly kept a lot of legacy businesses alive. So we talked about taxis, for instance, and taxi companies associated that their immense physical footprint and the number of taxi people involved just made it too complex to be replicable in a data-based environment or a data platform. But finally, we got to the point where streaming and big data technologies allowed us to finally surpass that. And frankly, we are seeing that across every part of business. We are seeing these ecosystems that have millions and possibly billions of parts that have traditionally been considered too complicated to work in an IT world. So they are still running on 30, 40-year-old operational technology, but we're still starting to finally get to the point, partially thanks to work of Kishore and many other open source projects that have helped with streaming and input output and indexing rather than specific data, change data capture, all these things that are happening to make us stop thinking about data simply in terms of having to rip and replace over and over again, and starting to actually think about data at a granular level, at a real-time level, and at the massive scale necessary to replicate real-time processes. So a lot going on here.
Yeah, those are really excellent points. And I just had to Google the Heisenberg principle here to take a look at it, but you're right. I mean, it's so because there are so many possible feeds, and I think that's kind of where we are right now. It's almost like the smorgasbord now. And Kishore, I'll throw it back over to you to comment on this. There's so much information you can pull in from so many sources, but where is the signal? How should you prioritize where you focus your attention from IT perspective, from a data perspective, and from a business decision-making perspective? And I think you are providing this real-time capability that, again, can save tremendous time down the road, right? I'm a big fan of cliches. There's an old one, a stitch in time saves nine. It took me years to figure that out. I'm like, oh, because if you wait, then you have to do 10 stitches. Right? If you only do one, it's fast. But that's what we're talking about, right, Kishore?
No, no, absolutely. I think the one of the key, this is something that I actually use this graph, which is the data has, most people think the value of data is constant over time, but it's not. I think that's the fundamentally the most important thing. It actually loses value very significantly, and especially in like the initial part of the time, right? I mean, let's say there is an event right now, the value of that event is like is probably the highest if you can act on it right now. If you act on it probably a few minutes from now, it's very different from right now. And if you act on it tomorrow, it's like completely different. You might probably not get any value out of that. Right. So I think that's very critical for us, for every business to understand. And the other part is all data are also not equal. Right. So some of these events are good to be collected, but you probably cannot really act on it immediately. Right. So I think for businesses, it's first and foremost, it's important to think about the whole architecture, and then make sure that you have the capability to harness the power of these events when you need it, right? Because some of these events may not be valuable today, but guess what? There might be some breakthrough in your product or some breakthrough, something else that happened. Suddenly, this becomes very important, and that you don't. That's not the time when you want to go and re-architect and re-engineer your whole stack to say like, oh, now I need to access to this data. So
Right.
it's important to be prepared, and then and what happens is once you have this kind of a framework in a company, there will be people, and when you democratize this data and access to this data, they will come up with products that no one could actually think of, right? And I think that's how business should think about in terms of making sure that they have this architecture and then they empower the people within the company to come up with
Yeah.
this really cool data products. And that's kind of what happened at LinkedIn. I mean, we just did it for who viewed my profile as the first product, but guess what? There are like 100 products right now, and they're all like real-time analytics.
Wow. That's a great point. We're going to go to our first break here, but we'll pick that up after the break. That's an excellent point and a good segue into data products is what we're really talking about here, and being able to create data products and then monetize them or use them to make your business more efficient. There are lots of things that you can do, but you got to get over that first hump. You got to get to the point where you can create these products and understand what they mean. But folks, we'll be right back. You're listening to DM Radio. All right, folks, back here on DM Radio, talking all things real-time analytics and observability. We've got Kishore Gopalakrishna from StarTree on the call, formerly of LinkedIn and Yahoo before that. And we've got Hyoun Park from Amalgam Insights on the call as well. And, right at the end of that segment, I'll throw this over to you, Hyoun. Kishore made a really good point about data products and about enabling your teams to see the kinds of data necessary to give them the ideas and the material to build these products. And then once it's built, then you can roll it out and let people use it. And it's my experience when people get a good data product, they just love it. You sit there. I mean, Google is kind of like a data product, right? You just ask it questions because they did a bunch of work behind the scenes to index the web. This, of course, started at Yahoo, and it's where Hadoop came from, really, was indexing the web. But once you've got it, you love it, and everyone loves it now. And now we have Gen AI and all these other things. There are always some issues to be sorted out, but nonetheless, when you get a good data product, people use it, and then they start making better decisions. And so that's really the snowball we want to go down the hill here, is to get that excitement in the organization to figure out what these things are, and then really start building them and using them. Right, Hyoun?
Right. And from a practical perspective, we've wanted to turn data into products for a long time. But what makes it hard is that there are so many different pieces to this.
Yeah.
It is easy to be a technician and simply say, we have created the data store, the initial single source of truth that we're going to use from a data perspective, and say that's the product. But from a reality perspective, you also have to think about the analytics, the outputs associated with that data product. You have to think about the ongoing maintenance of that data source and the outputs, the infrastructure that's involved, which obviously we've wanted to throw this all to the cloud, and starting to see that perhaps we need to pull some of this back in-house over time, especially as
Right.
we're starting to think about AI.
Right.
And then also thinking about just how this is going to scale over time, because honestly, we are all living in a world where things like Moore's law and just the growth of data are just relentless. Everything is doubling every 12 months, 18 months, 24 months. You can pick your time period, but the end result is basically every decade, we're seeing something like 100x growth in everything that we build. So anything with that we build today in 2024, we just have to assume a decade from now, if we are successful, this is going to be 100 times bigger at the very least. And this is even without assuming that you have great growth and 10x or 100x your company, in which case you've got a 10,000x challenge compared to what you have today. And your architecture and data plans have to at least take that into account, the potential for that success and the ability to move forward and adjust your data, the velocity of your data, the variety of your data over time to account for these inevitable changes. This is predictable. This at least this growth is predictable, that it's going to be massive.
Yeah, and it's a good point, and it's also important to note that at certain stages of growth, things change. You just get a whole different dynamic. You see this in companies like 1 to 10 employees is very different from 50 to 100, which is very different from 1,000 to 5,000. And you need people who can manage in different ways. You need people who can articulate and communicate in different ways and partner, and all this comes into play. And then you see the same sorts of dynamics in systems. When systems go from one node to 10 to 100 to 1,000, you run into different problems. And Kishore, I'll throw it over to you. That's the kind of stuff you folks experienced at Yahoo and at LinkedIn. And so you have the experience, you know what it's like to go hacking through those forests. And it's, I'm sure at times bewildering. And this is where a lot of the good ideas come from of like, hey, wait a minute, if we can instrument this one system, then we can get a feed to understand what's going on. That's kind of where observability came from, right?
No, no, absolutely. And I think you mentioned about the scale. It's funny. I really got into this because of the quote at on distributed systems is like it's funny that your system is rendered completely useless because some other system is down somewhere else, and it's
Right.
like you just you can't really grasp that. Hey, my system, why is it useless? Because something else went down somewhere else. That's the real challenge of a distributed system, right? It's like something goes wrong somewhere and then something else is not working, and then you need to somehow correlate all these things and get to the root cause. And I think for me, you mentioned about observability, but it's been there for a long time, right? I think, but the two important things in observability is really the MTTD and the MTTR, right? It's like how long do you take to identify the issue, because there's so many issues that just to go unidentified, right? And we used to have this chart. We had like a big black hole in the center, and we would say like how many issues actually were here that you probably realized 1 year later, because it just continued to become bigger and bigger, and that's when you realized. And this was like, hey, you launched a feature 6 months ago, and suddenly you get to see the impact of that now, because it's just no one was tracking the exact impact of that. So the first one is the MTTD, which is how long do you take to identify. And the second part, which is actually very important, and most people actually ignore this, is the MTTR as well, because you can't really fix the issue unless you know why it happened. So that question
Yeah,
of
right.
why is actually super critical. And most people just focus on the first part of detecting. And that's actually sometimes a lot more easier because it's right in your face. It's like your revenue is going down, or like the number of traffic, number of visits to your company is actually going down. But going from there to actually fix involves this intermediate step of figuring out the root cause, because you are just looking at the symptom and you have no idea what the root cause is. So I think observability is needed for the second part as well, because that's where you will be able to correlate. It's not just one data point that you can actually look at. It's, to your point earlier, is like how many feeds do you need to collect? How many data sources do you need to actually observe? I think that's so. I think overall, in terms of observability, it's about making sure that you have access to all these data points and all these events. And it might be sometimes the CPU, it might be sometimes the memory, it might be something completely different that you had not even thought about. And I think it's really fascinating to be in a stage right now where logging these events and collecting them is no longer a challenge, right? And that used to be a challenge for 10, 15 years ago. And I mentioned this in my keynote as well at Yahoo. We used to have this T-shirt that every event that you log, a kitten dies somewhere. And this was to discourage people from logging event because it was so expensive, right?
Oh, no.
So like imagine going from that era to like you're pretty much tracking everything, and even if you don't want, your watch is probably sending your signals, health signals every second, every microsecond. So I think that to Hyoun's point of like everything is going to be 100x. Yes, that is absolutely true. It's going to be orders of magnitude. And what we need is systems that allow us to still analyze all this data, but the unit cost per analyzing each event drastically goes down, right? I think that's kind of how we see, and that's one of the things that we started off when with Pinot is how do you reduce the cost per query, right? How do we? So that's the way we looked at it. And if you look at Kafka, and it basically did the same. It's not like there were no event logging systems before Kafka. There was RabbitMQ, there was ActiveMQ, but it was what people didn't realize is the cost of every logging, every event was actually very high. That prevented people from logging it. But that
That's
changed.
interesting.
And that's what we are changing with Pinot as well. Like you should be able to query as many number of times, and you should not be thinking about, oh, what's the cost of, oh, I asked this other question, is it going to increase the cost? And that's where data warehouse actually didn't deliver on the promise, because if you look at the cost per query on a data warehouse, it's very expensive compared to the systems that we have actually built.
Well, and this is, and so just for our audience sake, median time to identify and median time to resolve, right? These are the metrics that you're talking about, and it also has to be tracked. Like, how long does it take you? Is it a minute? Is it an hour? Is it 5 hours? And when it gets really bad, it's like, okay, guys, something's going on here. We got to retool and rethink things. And Hyoun, I'll throw it over to you just to help our audience understand. I think it's so fascinating what we've seen again coming out of these tech giants, because they realize, like Facebook goes and creates Cassandra because they realized there was no database in the market that could do what they wanted to do. The scale was so significant. It's not like they can go buy SQL Server and run Facebook on SQL Server. It ain't gonna happen. Like it just, and so they had to roll their own, right?
Yeah, and also we've been running into a new era of IT observability, where we really have been able to think at the packet level and go from network observability, application-based observability, database observability. And these all used to be separate systems that we all had to coordinate to get things done, because each system actually looked at a different level of IT activity. And then we had to kind of align all these to figure out what was actually happening at the most granular level. Now we actually have the data tools and to be able to look at activity in near real time. I always say near real time because somebody's always going to quibble about whether it's a millisecond or a nanosecond or whatever. But I will say that if you're looking for what's happening within the last few seconds, we have the technology now to figure out what is basically happening in near real time. And that really opens up a new level of visibility from, I would say, going one step back, thinking about data as a product. Now we can actually think about the margins associated with each data product, because we actually know how much it costs to run a data product to a greater extent now. Whereas before we had to do a lot of guesses. We could look at this network part, we could look at the storage part, we could look at this compute part, we could look at all of our separate systems. But now we're starting to have this one actual view of, at that lowest common denominator, of the actual data that is involved across applications and transactions, and saying, here's the actual cost of the application at the end of the day, or the product that we have at the end of the day, and be able to make better business decisions at the end of the day, which is, I think, the more important and practical aspect of all of the progress that we were making from this IT and data scaling perspective.
Yeah, that's really good stuff. And Kishore, I'll throw it back over to you to get back to this key point, which is concurrency, concurrent users. in the data warehousing space, companies like Teradata spent years engineering to be able to deliver concurrent analytics because it gets kind of hard. If X number of people are all hitting these tables and those tables, things are going to slow down. That's going to cause trouble for concurrency. And so they had to engineer for that. And here with a company like LinkedIn, with a service offering like LinkedIn, think about how many users you have logging on all the time. So you need to have a distributed architecture. It needs to have tremendous failover capabilities, and it needs to be able to break things down into little bits and processes as the use cases come in, right? As the activity increases. And everyone who logs on to LinkedIn knows it's like all you take it for granted. All that stuff is there, but there's a whole lot of engineering that goes on in the back room to enable that kind of scale, right?
Yeah, no, absolutely. And I think one of the things that we did was to first understand the how data warehouses were solved, how this because this has been there for like 10, 20 years. And I think one of the things that I definitely didn't want to do was build another database because I had built one before Apache Pinot and I knew how hard it is and I tried every possible thing to not build another one. And then it's
That's
that
funny.
to your point, I think it's fascinating when you actually go to the first principles and then see like why is this not working in data warehouse? I think one of the key insights that we found was most of the databases approached it from the fact of from the angle of this is the amount of work that we need to do to serve a query. How can we make it fast, right?
Yeah.
But that's where we came up with a different my approach, which is like maybe we shouldn't be doing this much amount of work. Can we actually reduce the amount of work instead of trying to keep the work the same and then try to do it faster by doing SIMD, by doing columnar, by doing distributed architecture? Those are all like things that people had applied. And that's where we came up with a different approach of like, maybe we shouldn't be doing all this work. How can we eliminate the work instead of trying to do the same work faster? And that's
Mhm.
where the idea of indexes were born. And
Mhm.
we kind of went all in terms of thinking of indexes as a first class citizen, not like a nice to have and an add on later, right? So we kind of went all in on indexes. We went all in on real time as well because that's another part that data warehouses didn't. It was always batch load that you could do in terms of data warehouses. So we wanted to be able to ingest data, and we put a very, very hard line on there is no micro batching. There is no, oh, we'll do like 1 minute, 5 minutes, because the challenge with these micro batching is like once you fall back, you're never catching up.
Hmm. Wild.
It just keeps going, and people don't realize this, and
Interesting.
they try it out in like one or two simple use cases, and then they think like micro batching just works. But the reality is, once you fall back, it's like very very hard to actually
Mhm.
catch up, and because the volume just keeps increasing on the other side. So for
That's
us, that's kind of I mean, we did a lot of work in terms of addressing this, but
mhm.
that's kind of what helped us to achieve all the requirements from the application.
Yeah, that's an excellent point. You reminded me of something I learned years and years ago when I used to play soccer and I used to run a significant amount. If you're running a long race and you fall behind a good bit, oh my goodness, it's over, man. You just because you can't you realize that you cannot accelerate fast enough to catch back up. And that's what you're talking about is you
Yes,
fall
exactly.
behind with this with these batches and then you're just buried. And then it's
Yep.
over. And then you've defeated the whole purpose of what you're trying to do in the first place.
Mhm.
But
Yeah, I
folks,
mean,
don't touch that dial. We'll be right back. You're listening to DM Radio.
awesome.
All right, folks, back here on DM Radio, talking to a couple of experts in scale out architectures. Very cool stuff that happens at places like Yahoo and Amazon and Facebook and LinkedIn. And these folks, the engineers who built these systems, I mean, they have seen problems like other engineers have never seen. And so you learn from that and you figure out your way to kind of hack through all this. And we wanted to talk with Kishore again about from StarTree about this concept of a disaggregated stack and what I call meta observability. So, observability is being able to see a data feed, let's see from a cluster that's telling you how it's performing, what is the CPU usage, what is the storage usage, what's the network look like. These are basic metrics that you're looking for. But the key is to be able to reconcile and correlate across multiple different environments and make sense of all that, and that's what I call meta observability. So, Kishore, tell us what you think about that and what StarTree has done to enable this next generation of observability.
I think one of the things for me is to understand what goes behind the scenes for any observability platform, right? And this is pretty much common. I would even generalize it to pretty much any analytics as well, which is you're really at some point collecting some events, and then you're storing those events, and then you're analyzing and querying those events, and then you're visualizing. So this thing can pretty much be applicable for everything. And what used to happen in this was there used to be all-in-one solutions, and there's for a good reason. There was a lot of pros and cons, pros about that in terms of it's very simple to get started. You don't have to understand all these bits and pieces, like what goes on in each and every stage of this. But the challenge here is always the all-in-one solution always had some limitation. They had to do some trade-off. They cannot solve every problem that you want to solve, right? And that's where most companies kind of hit a dead end because they start off with this all-in-one solutions. They're really, really good at one thing, but they had to do some trade-off because their main goal when you build an all-in-one solution is very easy to get started. It's a black box and it solves your problem, right? I think that's the, and it's really good. And don't get me wrong, I think there is a lot of benefit in having such a solution that gets you going very fast, but you cannot go very far with that. And I think that's where what we are seeing right now in terms of observability is this kind of disaggregation. And we saw this in analytics world and the big data world as well, right? I mean, if you go back 20 years ago, Oracle used to be everything, right? You collect your data, you store your data, you do your OLTP, you do your analytics, you do everything. But over a period of time, each part of this stack has become so complicated that you actually need a completely different system, right? And that's where collection has become very unique. And then you have these streaming systems like Kafka, Red Panda, and all these other systems that have basically become standardized there. And they do only one thing, do it really, really well, right? So now you can actually log all these events. So similarly, what is happening in the observability is like there is a lot of things to observe, right? And initially it used to be just metrics that you mentioned about network and CPU and all these things, but that's very limited if you look at it, like what you need to solve and what are all the things that needs to be observed. You need to observe your business metrics as well. So it's not just your CPU metrics and machine metrics. What about your business metrics? How much revenue, how many signups, how many connections? There are so many other things that needs to be observed. And logs is another one, right? And it's not just the metrics. Now you also have logs, and then you also need to correlate these logs and then the traces as well. So in a way, observability is like metrics, events, logs, and traces. So all four of them are actually very important, and you can probably fit each one in one of these buckets. And you need to correlate all these different things. And that's where we kind of go back and you see this all-in-one solutions, one for metrics, one for logs, one for traces, one for events. And that's very, very hard for companies to actually start making kind of a cohesive story and be able to root cause across all these different systems. And that's where my view is that this is becoming standardized in an horizontal way. So that way you can actually say like, hey, you have a collection system, you have a storage and query system, and then you build your data products on top of it. And that make sure that you have no access to all these different systems. And to me, that's where the meta observability that you mentioned, which is another app that comes and sits on top that basically interacts and interoperates between all these things. And the nice thing that happens, Eric, with this is you get standardization of APIs at every level, right? Like if you look at storage, S3 has become like a de facto standard. Yes, it becomes very popular. If you look at messaging, Kafka has become the standard in terms of messaging APIs, right? So that's really good because now you can build on top of something that has already proven, and there are different systems that actually provide that capabilities, and you get the best out of in terms of the app or the tooling that you are actually doing. Because when you talk to anyone in observability, the biggest challenge they have is like, oh my God, I have like 10 different tools that I need to go to solve one.
That's right.
It's a big problem. And that's what I see in observability, which is there is growth for standardization on the horizontal layer.
Yeah, and I'm going to bring Hyoun in to comment on this. Hyoun, here's one thing that gets me super, super excited about AI and machine learning in general. We're talking about all these feeds coming in from different systems. Well, there's the real-time reality that you have to deal with, and that's, of course, what we're talking about today. But then in the background, if you have the right setup and you know how to set up these algorithms, you can be crawling around through all this historical data looking for patterns, and eventually you'll see something and say, wait a minute, every time X, Y, and Z happens, something fails. Well, what the heck is going on there? And that allows you to dig deeper and figure something out. In this whole world of site reliability engineering and all these folks who are just all day long dealing with tickets and just trying to solve what the heck is happening out there. That's very powerful because you can find one recipe that says, wait a minute, when these four things happen, that thing happens all the time. Put in an automated process that look for that and say, oh, that happened, ding, do this, restart those servers, do whatever. That's how you really start getting somewhere and get to where you're not behind the eight ball. What do you think, Hyoun?
Yeah, so we've made it this far without bringing up generative AI, but here I am. Here I'll go there.
There you go.
I do think that the important thing about generative AI is that it has provided us with a way of thinking about AI from a behavioral perspective. We don't necessarily have to think about how to look at things just from a specific rules-based approach, but we are starting to be able to think about things in an ecosystem approach. So this doesn't necessarily mean, okay, we're going to throw ChatGPT at this problem, but we have this bigger picture, large language model, as well as ecosystem-based AI perspective that we can now start bringing into observability challenges. And this helps us to augment what we kind of think of as our gut feeling or our experience, our 20 years experience in having looked through so many tickets and so many challenges and so many alerts and so many things that come from the anomaly detection side that we have seen over and over and over again. Now we have this systematic way of also starting to think about observability and alerts and fixing issues that can hopefully work with the way that we think, rather than it be a conflicting way of thought or something that is so hard to set up that we never actually bring it into production, which was kind of the problem with this last generation of process automation technologies and kind of the observability 1.0 world, where something like Datadog is definitely useful, but it's starting to get so overwhelming that you just can't go through everything that Datadog shows you without having yet another tool to actually help you sort through the avalanche of content that exists.
That's a really good point. And folks, if you want to get a gander what we're talking about, just go online and search for observability and like companies like Datadog and New Relic, and just look at what you get. Splunk. I went to the Splunk conference a couple weeks ago, and I'm looking at the screens and what they're dealing with, and man, like it's like the Matrix, in the Matrix, and they have all the numbers falling down from the sky. That's kind of what it feels like. You're like, what does all this stuff mean? You need someone to explain that to you. And kind of to Hyun's point, a very interesting development now is that Gen AI is very good at explaining things, at least concepts that have been widely published and upon which the models have been trained. And then there are many, many of them out there. For that kind of use case, Gen AI is very compelling because these are basically consensus engines more than anything else. They look for patterns, and when you train the data, it vectorizes it. So you're turning text into numbers or numeric values, basically vectors specifically, and then back into text based upon the prompt and upon the training and so forth. But the point is, it's a consensus engine, and so it's going to show you the average of what has been written about something, which a lot of times is going to be pretty darn accurate. And so you're going to see, I promise this is going to happen. Maybe Kishore can tell us in the podcast bonus segment up next. You're going to see Gen AI explaining how certain component parts come together and cause some of these problems. But you'll always have to vet it. It does hallucinate, so you got to watch out for that. But don't touch that dial. We'll be right back. You're listening to DM Radio. All right, folks, back here on DM Radio. What a fascinating show today. A Pinot for your thoughts. Next generation observability is here, and real-time indexing, real-time analytics. Kishore, I'd like to throw it over to you from StarTree to kind of comment on. We really dove right in there with understanding what the machines are all saying these days, but maybe close us off with some thoughts about real-time indexing and maybe how Gen AI helps bring this all together.
No, absolutely. I think one of the things that you mentioned there is the explainability of Gen AI, right? I think for me, the first part of that is really what is happening today is most of the Gen AI stuff is happening on static data, right? And this is you're indexing pretty much all the knowledge base that's out there, and then you're some sort of making some conclusions from that, and then answering the questions. But fast forward a little bit ahead, and when you try to bring in into the observability and everything, this data is not static. Now imagine you feed in this data for a Gen AI model like yesterday's data and ask a question, and then it's answering answering questions and based on yesterday's data that's already stale. Right. So I think that's what Gen AI and observability is going to make the problem even more complex, which is you need some system that is constantly updating the model based on the latest and greatest information that's coming in. So we are just getting started, in my opinion, on the Gen AI stuff. And I think the second problem is also it's more than explainability. I think it's more than, it actually puts a lot more onus on the users now. It's like, what kind of questions do you ask? Because it's able to answer a lot of questions because it has all the information, but it is also important for the users to ask the right question and to actually make the right decision, right? Because the root cause analysis is really about asking the next right question based on the answer from the previous question. So it's Gen AI is not telling you what questions to ask. So it's really on us to understand the response from the first question and then try to ask. I think technically, in terms of the challenge, it's going to be how quickly can we actually index this data, how quickly can we update the models based on all the changes that are happening. It's going to be a fascinating challenge, and I think it's getting even more exciting.
Well, and I promise you, there's a whole architectural side to these things too, and you're going to start seeing, if it isn't happening already, layers being put into the existing stack. A lot of that'll happen in RAG, in this retrieval augmented generation space, but some of it I'm pretty sure will handle in the models. And I heard some really interesting stuff recently. Hang on, I'll throw it over to you to comment on about the different models you have out there. And one thing I heard was that IBM with Watson, at least the initial architecture, and I think this is still true, was designed such that if you trained it on data that you wound up not wanting to have done, you could actually pull that data out and retrain it fairly easily. Because that's, I think, one of the Achilles heels with some of these other systems. It's like, I joke that training a model is like raising a kid. If you say the wrong thing in front of them, well, guess what? They're going to repeat that back to you if you use like the F word or something, and you can't untrain it. Like you can't untrain. You can tell it, don't say that word. Oh, it's too late. It's already in the memory banks now. But what do you think about that whole concept of retraining, fine tuning versus RAG model? I mean, there are lots of ways to solve these problems, right, Hyoun?
Yeah, that's kind of an interesting trade-off that's happening in AI right now. IBM took an approach that is very traceable and reversible because they have all these enterprise clients. But the challenge for IBM has traditionally been that they were moving too slow for the client base, whereas OpenAI has the opposite challenge right now. They are definitely moving fast. They don't care whether they break things or not. And honestly, so far, it's worked for them. They have $3 billion in annual revenue, something like that from a run rate perspective. So they're obviously succeeding. So it's hard to say that they're doing everything wrong when they've built obviously one of the most game-changing products of this decade. But be that as it may, one of the big challenges right now in AI is that we talk about models that are only accurate up to a certain point. They only have data that goes up to September of 2022 or April of 2023. And after that, you literally can't count on them from a factual perspective. And you can't actually count on them to reflect the logic that has changed over the past year from whatever best practices may now exist in a coding perspective or from a process perspective. And that's going to be a real problem because we're going to get used to specific types of logic and outputs that we have grown used to. And then we're going to find that the models have changed and not necessarily in a way that we like. So we're going to start running into new challenges where we say, I like this model. I actually want to use this model going forward. I like the way it works for my business, but now I'm getting pushed to this new model that may make assumptions I don't like. What if I want to keep the old model, but simply update the data, update the indexing going forward so that I can continue to use the model that is already the right model for my business? We're going to have a lot of these intersections and interplays that happen that we're not really well equipped to figure out right now. This is still very much a work in progress.
Yeah, that's a really good point, and there are so many factors, and that's kind of what we're talking about on the show today. Kishore, we got about 1 minute left. Final thoughts from you on what's your recommendation for prospects? What should they be thinking about or looking at?
I mean, I always, I'm a big fan of taking incremental approaches, but at the same time, keeping in mind, like, what do you need to be, where you need to be for in the next 3 to 5 years, right? I think there's a very nice thing that DJ Patil had actually written, like, plan in like 10 years and then try to make sure that you're executing ship daily, but at the same time make sure that your implementation is incremental. So many people, I think we saw this happen when Hadoop became like a big thing. Everyone just dropped everything and then
Right.
tried to say like it's going to solve all our problems, but I don't think there is any silver bullet for all these things. So just make sure you know where you want to be in 3 to 5 years, and then take baby steps, and obviously experiment. I think there is a lot of interesting things on Gen AI, but I don't think it will solve every problem. You
Right.
still need the fundamental things. You need the right data. You need the right architecture behind the scenes for it to be
Yeah, and the
used.
closing comment I'll throw out there is understand the tool. There are folks out there trying to give ChatGPT these complex math problems. I'm like, that's not what it's made for. It's made to generate text, to reflect back verbal or written language, basically. That's the whole point of this stuff. So understand the purpose of the tool and use the tools appropriately. Well, folks, look these gentlemen up online. Thank you so much for your time. Kishore
Thank you so
Gopalakrishna
much.
from StarTree and Hyoun Park from Amalgam Insights. We do archive all these webinars for later listening, so send them to your friends and send me an email, info@dmradio.biz if you want to be in the show. We'll talk to you next time. You've been listening to DM Radio.
Thank you.